starting on problem 3. This morning I played social tennis outdoors. The outdoor season has just started, and the weather here at the end of April is about 10 degrees Celsius, even if we had sunshine. So I can feel a little in the throat, but let's try to get this problem done with. So it's doing almost the same as in the last problem, but now n equals 5. The point of order 3 I've taken from page 41 of the book, and the ones from order 4, the work I told you about and showed the last computation last time, I've noted here. So there are 12 possible points of exact order 4. Those where 2 times the point lies in 0.0. For those to exist, square root minus 1 and square root n must lie in the field. Here it's fp, of course. And to hit n point null, square root 2 and square root n must lie in the field. And the one I showed you last time, if we want to hit it in minus n point naught, square root 2 and square root minus n must lie in the field. I didn't do it quite right, so we just have to correct it a bit here. This was right. This gives 2 plus minus 2. So it should be plus here and plus minus there. Am I right or am I? And then we don't get. This was not what I expected, because this I have to take them 2 at a time, so just take all this out. And first check. This is the x value minus 1 plus minus, and squared it gives 3 plus minus 2 minus 1, that's 2 plus minus, so that's 1 plus minus. So if we use the plus, then it's square root 2 plus 1 times square root 2 minus 1, giving unity times 2n to the third. And if we use the minus sign, then it's minus 2 plus minus 1. That still gives unity. So we get 2n squared. I'll just make a paused check because that disagrees with what I found here, or what I found earlier. So a little break where I sort this out. That took a little while. I had to go through a lot of calculations. There we go. So I tend to believe now that this result is correct, And that means that we have to have square root 2 n lying in the field. But since square root 2 already lies in there, it's sufficient that square root n does as well. So that means that I believe on this page that's a big one, that we just need to delete that minus. So it's just square root n again. And that means that here we get 8 points. We'll have to check that, of course, when we come to it to see that it is correct. If we get occasion to do that. So let's get started on the problem. P equals 3. Now the group, the elliptic curve, 5, n equals 5, of fp, and I'll try to use additive notation this time. There are 4 elements, and that must be the ones we know are there, so the type is 2.2. P equals 5 has pretty bad reduction, so P equals 7. There we have P plus 1 elements, so it must be 2.4. So let's write it 2 square, yeah. The next one is 11. It's also equivalent to 3 modulo 4, so we have 12 points. The type must be 2.2.3. P equals 13. The number of points need to be found. I prepared a Maple script to do that. We define the function f of x, then we define the prime, 13, then list the squares, and there should be 6, non-naught, as there are, and then we see how count the number of points. That was quite a lot. So there are the 3 of exact order 2, and the rest is 1, 2, 3, 4, 5, 6, 7, 8 x values giving 16 points. So with the 4 of order 2, that gives 20. So we have 20 points. That was quite a lot. On the other hand, it's just 2 to the 4th times 5. So it's 2.2.5. Since we have 4 points of order 2, it can't be 4.5. The next one is 17. Here we need to do the same work. So just run the whole script. One, 2, 3, 4, 5, 6, 7, 8. There's 20 points here as well. The result must be the same. So we get some points of order 5 in these groups. The next 19 is 20 again, so the result is the same. And finally, the prime 23, which is 3 modular 4. So the number of elements is 24, being 8 times 3. So we will have elements of order 3, and then we need to find out the elements of order 4 to see how many we've got. So there are two possibilities now. 2.4.3. That's the only one. So we just have to want to verify the number of elements of order 4. So we want to check whether square root 5, square root minus 1, and square root 2 lies in the field. So let's do it without using Mabel. So minus 1 times 23 equals minus 1, 2 over the index of 2 over 23. That's minus 1 plus minus 24, 3 times 8 minus 1. So square root 2 does lie in it. And square root 5. This is 4 plus 1, so we can just flip it. And 5 is still plus 1, so we can flip it again. So square root 5 does not lie in F23. We'll just check. What exactly should I see? I should see if 5 was a square, and it isn't. And that should lead to the conclusion that we have no point of order 4. Oh, let's just change this to 23. That would make life easier. So 5 is still not a square. And the number of points, it would be silly to check them, wouldn't it? Just do it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Altogether 24. But 5 is not a square root. I mean, 5 is not a square. Square root 5 does not lie in it. neither does minus 5, for that matter. Uh, 23 minus 5, that's 18. So minus 5 is a square. So maybe my first calculation was right, since minus 5. We'll just check it. The points of order 4 here. So square root minus 1 was not, but square root 2 was. And that means that we have a point x naught equals n. It's impossible that we have no points of order 4. We must have a point of order 4. Or rather, 2 points of order 4. No, I mean 4 points of order 4, of course. I was thinking about what was the best way to do it, and one is to find the points and then simply double them using the equation. That's a slow method, but then we get full control over the points and everything. So we have to double the point can be minus n point naught or n point naught. So we'll just use the two formulas I have for the x value, find the point, and then double it. So that's the prime, this is the point, n point naught. And the point I have, or the x value, is 1 plus minus square root 2 times n. And we need to find square root 2. That's 12. Minus 11 or 13 times 5 minus 55, 65. We have 3p is 69. So this guy is minus 4. And 55 from 69, that's 42. 2p is 46. That's 9. Now let's use Mabel. Minus 4 and 9. 13 is a square, whereas 21 is not. That means we get only 2 points of order 4. Of course that's possible. How could I miss that? So the 2 points of order 4, we need to see what actually so I'll just do this one more time where we get the table of squares so we can make the square root. There we go. 13, that's 6. So it's minus 4.6. Right. The slope at this point is, now what was that? The derivative divided by 2 times y. I'll just make it the derivative equals 3x squared minus 25, and since we are modulo 23, 3x squared minus 2. Uh, 1632, that's 9, minus 2, that's 7, divided by plus minus, we just take plus, divided by 12. So it's minus 4.6. Let's see if it can do this. That didn't work. Oh yeah, no, the slope shouldn't be naught. That's strange. Well, this shakes my intuition totally. Now, minus 4, 16 times 32, that's 30. 50, that's 7. 3 times x squared minus 21, 25. 3 times x squared, 32 minus 25. So it's very adamant here, and I just don't understand it. So let's try another number, 2. That gives something sensible, though it's a little strange. Now, what was the other x value that didn't exist? Oh, never mind. Another break to sort this out. Just a little remark before I make my coffee and look this over once again. There has to be none or 4 or 8 or 12 points of order 4. So the cognition that there might be 2, of course, seems to be wrong, considering the group structure, and then also considering my previous calculations, which all showed that if there were 2 hitting 1, 0, or 1 point of order 2, then there would be 4 altogether. So that's, but my coffee haven't, it's just finished, but my cookie hasn't yet thawed. I have them in my fridge, so, or rather in the freezer, so it takes a while. Of course, the point we found, minus 4.6, there is a horizontal tangent, and that's very possible. Also, in the real part of the curve, we have a point with horizontal tangent on the little round-like part. On the left, we have 2 points with horizontal tangents, and then the other curve. Well, so that's possible, but then that cannot be a point whose double lies on the axis, so it's the wrong point. So square root 2 is wrong, and now it turns out that square root 2 equals 5. 5 squared is 25, and that is equivalent to 2 modulo 23. So the square root of 2 is 5. One plus minus 2, that's minus 1 and 3, so it's minus 5 And 15, that's minus 8. Now what was the first one? Minus 5. Oh yeah, we know that. Can't be 5. That's silly. That's really dumb. I should have seen that immediately. Can't be. Square root 2 was 5. So this is where we should... Oh. One plus minus 5 times 5. 6 times 5, that's 30, equals 7. Minus 4, that's minus 20, equals 3. Let's take them one at a time. And let's do it down here. And we just check it all in Maple. The first point is 3. (21), that's minus 2. Two should be a square. It isn't. Oh yeah. This goes too fast for me. Let's do it once again from the start. 1 minus 5, that's minus 4, that's minus 20, equivalent to 3. Or should we just say equal, henceforth? So f of 3 equals 21. The y value, no square gives 20. 21 is not a square. So that means that that point now let's check the other one. 7. 6 times 5, that's 35. No, that's 30. That's 7. Let's check 7. Seven gives 7, and is 7 a square? No, it's not. So that means that those two solutions fail to work. No points. Next. that's just changing signs. I've become uncertain of myself, so I'll just do it again. Minus 1, it's 4, that's 20, that's minus 3. Good. So we change sign. Minus 3 first. That gives 2, which is the square. Then minus 7 should be as well. Or f of minus 7. That's like 4 squared. So we have I'll just write up the point here. Minus 3.5 and minus 7.2. That's the point. So the slope and then this mod p should be at the end. That's 14. So minus 3.5 has a slope of 14. And we should go 2 to the left, so we should end at 5 minus 14 times 2 equals 5 minus 23 equals 0. So that point works. So we actually have one there. Whatever my computation said, and we'll just check the next one as well. That was minus 7.2. That gives 19. Or minus 4, and we should go up to minus 5, that's 2 to the right, so we should go 8 down. So something's wrong here. Now, is the point really minus 7 times 2.2? One minus 1 minus, that's minus 30 plus 23, that's minus 7. and minus 7 gives 16. The square root there is rather 4. Would you say it's rather 4? That gives 21 equals minus 2. And then when we go 2 to the right, we go 4 down. So we have improved very much. Maybe it was minus 7.4. Could that be? Yes, it was minus 7.4. Finally, I got the point. Now, I definitely need to change. What about the point 0.0? Is that possible? And when that's done, I need to turn this off and then find the error in my computations. That was the whole point of doing this calculation, was not that I hadn't solved the problem, but to find out whether my general knowledge here was correct, which it seemed not to be. I doubted it at least. So x equals plus minus square root of minus 1 times n, 5. So or plus minus square root minus 5. And that's of course 18 here. 18 is a square, and it comes as 8 squared. (64 minus 69 gives minus 5. So it's plus minus 8. And as we see, 13 is a square, and I thought 10 was a square as well. Well, minus 1 does not lie in this field, so one of them have to be a square. So we actually need to have one of the points. And that's 8.6. So we have the point 8.6 and a slope of 12. And when we go all the way down to naught, then delta x is minus 8, and m delta x, I'll just do that in Maple. And it's better to write it as that gives 19. So we do not hit naught. So that means that it seems my formulas for some of the points are wrong. Not all of them, though. This is quite surprising. So I'll take a coffee break now, and when I'm finished, I will go through the algebra once again and maybe making numeric computations to find the errors. And then I'll report what I find. It's now half past 3 p.m. I have had my coffee and I found the error. What I did was that I went back to Mabel and made an example with the prime 7, because we knew there should be elements of order 4. So I wanted to find them, and I made a little test that first checked that first it writes the point, then f of x, then y squared. So that's testing that the point actually lies on the curve. Next, it prints the slope of the tangent at the point, and then where that tangent intersects the horizontal axis. All very simple. And I went down to p equals 7, and I'm writing Danish here. Well, first, those hitting at 0.0 do not exist, because -1 is not a square in F7. Hitting 5, the x values exist because 2 is a square. It's 4 squared. No, 3 squared. It appears to be 3. So the points now this point f of 1 is not a square. F of -1 and f of -3 is neither a square. However, the ones hitting in -5 are squares. So that means that we have 4 points here, and that's all those 5 is still not a square. And testing 1.2 and 3.1, of course. So we see the point lies on the curve, and it intersects in 2 modulo 7, which equals -5. So we have actually found 4 points of order 4, and 3.1, of course. That means that the condition is that square root -5 lies in the field. So going back to this computation, there must be an error. And it's not hard to see that it must be in this part. And I went through it without finding the error, which is embarrassing, but all right. Now, copying this guy, I did correctly. Squaring it, I couldn't do that correctly, because we get -1 times plus minus. So we have to change this guy to minus plus and this guy to minus plus. So now it won't write. I did solve it. Oh, it stopped totally. No, it's still working. Minus, plus. Let's try another pencil. They have opposite sign. So this, of course, is all wrong. So it's minus 2n to the third minus 1 plus minus square root 2 squared. And that means that it's minus 2n, the square root of minus 2n times n squared times the parenthesis squared. So it's minus 2n, which must line the field. And that means that minus n must line the field here. And then we have 4 points of order 4. And of course, if square root 2 lies and the prime is 3 modular 4, then only one of these conditions is fulfilled. So this will give 4 points. And that's exactly what we had on this page. P7, we have here 4 of order 4. We have 2 from here, and then they may be multiplied by the unit or by this element or not. So it gives 4. And the same here. We have elements of order 4 because 2 is a square. So either 5, then minus 5 is a square in the field. So it gives the 4 points of order 4 that I was missing. So now I think I know everything there is to know about this problem.